We want to find the value of x. Now, following my normal practice, I would call this side A and this one A. And then this one could be B and B, or C and C. We know that A over sine A is equal to B over sine B. Substitute in what we know. So 25 over sine x is equal to 30 over sine 70. Now I'm going to come back to this step and look at it on the CAS shortly. If we want to solve just on the ordinary calculator, then turn the fraction upside down on each side. And then the 25 is dividing on this side, so multiply both sides by 25. And we get sine x is equal to 25 times sine 70 over 30. And so x would be the inverse sine of 25 times sine 70 divided by 30. So we can do that. The inverse sine of 25 times sine 70 divided by 30, and that gives me 51.5 degrees, correct to 1 decimal place. Now I said I would come back to here, and let's do that. So on here I can go solve, and then 25 over sine x is equal to 30 over sine 70. Now, when I hit execute, look what it gives me. The angle that we want is this one, the 51.5. But what I'm going to do, in order to not get all of this, there's actually an infinite number of solutions to this equation. And what we have here is the calculator's attempt to give me those infinite solutions. In Math 3, I've got a given line. You use that for probability, but you can use it elsewhere as well. And I'm going to say that I want my x to be between 0 and 180, because it's in a triangle. Now when I press execute, I get two answers. I get the 51.5 degrees, but I also get a 128.5 degrees. Now, just to point something out here, the calculator's not gone mad. If I do the sine of this angle, and then I do the sine of this angle, I took the different numbers of decimal places, but pretty much we should get the same answer. So both of these angles are solutions to this equation. The question is, do they both work for our actual triangle? And in this case, I think the question is no, because we already had a 70-degree angle. And 70 plus 51.5 degrees, well, that's absolutely fine. That's 121.5 180.5 degrees. That means with 180 degrees in a triangle, there's room for the third angle. But if we did the 70 we knew already, add 128.5 degrees, well, that's 198.5 degrees, which is more than we can have in a triangle. So we can't get a third angle. The question is there a situation where both of these angles could be valid answers? And the answer to that is yes, as we will see in the next example. I would always check both answers.